Hi, my name is Dennis. Welcome to Foundations AWS Well-Architected Framework and Pillars. Let's get started. Our learning objectives include explaining the 5 well-architected pillars inside AWS. We want to identify the best practices and deviations from well-architected designs, as well as anti-patterns for non-well-architected designs. You will also utilize the well-architected tool inside your lab and understand the concepts and making business decisions behind conscious choices on how to get your workload inside AWS safe, securely, and optimized for your business needs. So, what is the well-architected framework? Well, in a nutshell, it's a framework based on the best practices, designs, and other principles that we all found out at Amazon Web Services through interactions with our customers, such as yourself and many others, tens, thousands, hundreds of different interactions and engagements. We documented what went well, what didn't go so well, and we consolidated it all into a single white paper based on our experiences accordingly. So inside the well-architected framework, there are pillars, 5 of them specifically to be exact, and we have them consolidated accordingly. We have the operational excellence, which is our first one. We're designed around making sure information is out there, automated as code as much as possible. We want to deliver the best possible outcome and experience, all the way from dev to the operations piece, hence DevOps. And we want to continuously improve on our design and provide that great business outcome and value accordingly in our planning and design and implementation phase. Next, we have security pillar. Security is considered job zero at everything we do at Amazon Web Services. And so that it's really gone down to our customers. We want to make sure that things are protected. Data is protected, infrastructure, as well as the authentication. Remember that the shared responsibility services, security of the cloud is responsibility by AWS. Security in the cloud is responsibility mostly by you. Make sure that you understand those differences as we move forward. Next, we have reliability. So, are we able to cover? Are we able to have multiple resiliency requirements? Do we need to be multiple regions, global, a single AZ? Would that be acceptable? What's our mean time between failures and mean time to recovery and our point in time recovery requirements based on the business needs? Part of that reliability also includes what kind of uptime we have, not just the amount of recovery time and automation that goes with it, but how long do we want to stay up, giving that best user experience back to our customers. We also have the performance efficiency. So performance efficiency include what's our efficiency on demand changes? How do we scale up and scale down? How do we make things better? How do we actually optimize all of our resources to utilize less resources over time and ultimately make a higher performing application and workload into the environment? This might also include utilizing serverless technology and also many other things that encompass moving away from infrastructure as a service and more software as a service or even platform as a service. And finally, we have our fifth pillar, cost optimization. Now, this sounds like it's give or take pretty obvious in itself, but however, you should still need to monitor everything. So just like you monitor any other program on premise or a traditional data center, for instance, you need to make sure that you're avoiding unnecessary costs and you need to actively monitor what is considered successful. Is everyone supposed to be using all these S3 objects and putting our costs into jeopardy for this project? Do we need to cut back on those costs? Can we cut back on utilizing it on demand? Can we use reserved instances and make contracts and get other discounts and other great things so we can be cost effective and in line with our business requirements? So let's dive a little bit deeper into the different pillars and the design principles that go with it. Now, inside operational excellence, there are multiple design principles and multiple best practices of those principles. We're going to be covering the design principles as outlined inside the white paper itself. Be sure to read the white paper in full after this lecture to get the better sense and idea of how to implement the well-architected framework as we move on. So the operational excellence includes performing operations as code. What does that mean? Well, if you can remember in the previous lectures, we also talked about infrastructure as code. Now, infrastructure as code basically defines, well, if I want a server or 2 servers, or perhaps a network and a host-based firewall, I can define it visually as well as by code only. And here we have CloudFormation using the YAML style template, YAML being yet another markup language, or JSON, which is JavaScript object notation. Here we show the YAML version of it, and we're defining what our architecture should look like. We're defining what we want in there. I'm not really defining exactly programmatically what happens at what occurs, what time. I don't need to worry about actually provisioning the product at the hardware level. This is all done for me because of the magic of the cloud. So infrastructure as a code base and your application should be deployed hand in hand inside a single stack. So remember that you don't need to worry about applications only being part of the code. You can still deploy your infrastructure as a code, such as your underlying servers, your operating systems, your runtime requirements. You want to make sure that you have that consistent. Remember, operations as code makes more efficiency and better resiliency and less mistakes happening because you have less human interactions, possibly making mistakes and introducing errors into your deployment. Next, we have make frequent and reverse changes. Now, on Amazon, we have things called one-way doors and two-way doors. One-way doors are big decisions or things that are hard to go back on, and we have two-way doors that are easier, smaller decisions usually that we can easily roll back and revert to our normal status if something goes wrong. Part of that is utilizing things like agile development framework models. Here we have things called sprints. Sprints are usually done on a weekly basis, and you might have backlogs of tasks. Those tasks are frequent and small enough to get done within a day or even a week, and they can be reversed at any time. So the less changes that you're making are not necessarily the best decision courses. If your changes are very large and you're making them less frequently, you could impact a lot more, and you have less time for testing in between, and you might have to roll back. It might take longer. So make smaller changes and roll back where you have to, because those little deltas or those little differentials make a bigger difference because you can actually keep developing faster and faster and make more resilient and robust applications and solutions and workloads into the cloud. We want to make sure that you utilize as best possible feedback loops as possible. So what do I mean by that? Agile development allows you to do that because you're iterating many, many times over a smaller subset of tasks based on what you need to get done each week. We'll learn more about agile development in later modules. But for now, focus on the fact that we want to make sure that we have smaller code changes. We want to make sure those are reversible, also known as rollback changes. And we want to make sure they're frequent so we can actually do lots of testing and experimentation. You never know when something's going to fail, so you should plan accordingly. Also, along with that continuous improvement, we also want to make sure we want to find operations frequently. So if something's not working right, such as we're doing weekly sprints, maybe we need to move it to bi-weekly. That's not just technology, but also process and procedure as well. So if something doesn't make sense or it's not meeting SLA, refine it. And over here on the left, we have the plan, do, check, act. So PDCA, and that's actually part of the ISO 9001 series. The ISO 9001 series is about quality control, understanding that we want to make sure that we do better, continuous improvement, continuous checking. So be sure to always test and test frequently as you evolve and create your workloads, that you want to make sure that your procedures keep up with the technology anticipations and use case requirements of your enterprise. Next, we want to also anticipate failure. Ultimately, a part of operational excellence is determining what makes sense in terms of business catastrophic needs, business continuity planning, and disaster recovery, also known as BCP/DR. Now, our point-in-time recovery and our point-in-time of failure and how often, what's our SLA to our users, what's our uptime requirements, those are all business decisions that you need to be aware of as you're developing and creating your production-ready workflow. So you want to anticipate those failures that occur. Something can always fail at any part of the chain at any point. In the architecture that we see in the left here, we see Amazon Route 53, which is a DNS service, actually. It's a global DNS service that allows high resiliency, high availability, and can scale accordingly. So you never have to worry about denial of service against Route 53, at least you as a customer. You also know that it's going to be always available and up and not a single point of failure based on the magic of AWS on the back end. Now, what you do have to worry about is your infrastructure and your understanding of what can fail. Here we have a whole A side and we have a B side. You might have the same hot environment where you need to do replication constantly. Let's say you have a mission critical business workload and it is imperative that you cannot have any form of downtime. You want to create a hot site to have that replication. In the event that this site A goes down for whatever reason, the DNS is going to switch the IP and the domain name to the traffic to this environment instead, and you should have the equal capacity, if not near real time restoration. So that's the point of anticipating failure. You need to anticipate failure at all levels. So even if it means that, regardless if you're using IaaS or PaaS services, you really understand that failures can happen anywhere, anytime, for any reason, and they may not be AWS's basic failure. They could be your failure from a product standpoint, a data processing standpoint, or whatever else happens inside your environment as part of your workload. Now, the next pillar is security. We have multiple design principles around that. Remember that at AWS we say security is job zero, and it really is. Job zero being the first thing that we think about as part of our trust to our customers. And really, you're that customer. We are that customer at the same time. Implements a strong and identity foundation. So basically, you need to make sure that you have a great definition of what your logical groupings need to be. How many users, what users need to be defined. Do you need to federate them with Active Directory on your local on-premise environment? Do you need to keep them segmented or completely isolated from a directory services standpoint instead of integrating it by federation into your environment? So maybe creating completely different users for different requirements. Should you use different policies and contexts? Should every user have the same level of access rights? And the answer is no. Now, pause the video and think about, from an analysis standpoint, what least privileges mean to you as a normal DevOps person, a security person, from an HR person. I'll wait. Okay, I hope you thought about it. Those security contexts should be different. The same privileges should not be the same for cyber security professionals, where you might need read-only access to the entire environment, but only write access to a certain set of systems, perhaps the systems that are monitoring or they control security around security of your cloud inside the environment, security in the data security portion itself, right? Your version of security, your responsibility. You might have also a different context around human resources. They may need only read access not to everything, but only to what their system. So basically their S3 buckets, their EC2 instances. So you have to really understand that is managed by policies. And you can have managed policies or inline policies. Ultimately, you attach them to a group or a user, preferably a group, and you say, hey, HR, you all have these rights, and you should be able to assume those rights based on roles or other directly attached privileges. Ultimately, the name of the game here is identify every entity, what their use case requirements are, and make sure you only apply least privileges accordingly. Next, we have enabled traceability as part of our design principle in security. Now, traceability is, you might argue, well, can't that be part of resiliency or performance? Well, that's part of it too. But remember, ultimately, logs are ways of tracking and auditing what has happened in the past so you can actually trace any kind of security related problems. Now, you see over here on the left, CloudTrail, EC2, S3, all right, all these are different technologies, platform as a service, really, with AWS. And regardless, you can actually send these to CloudTrail, and CloudTrail will have a, by default, JavaScript object notation or JSON set of streaming objects of what has happened, specifically at the API levels of the AWS console, CLI, or software development kit. Whatever you may do, remember that AWS, everything that you do is an API in itself. Those calls, requests, and responses are all captured inside a service called CloudTrail. So whenever you want to look at and think about security in terms of visibility, think about traceability. And those are almost certainly log and log-related information. Now, you also want to apply security at all layers. Remember that security happens at different layers of the OSI model, where you might think about application security as opposed to a network firewall rule at layers 3 and 4. Well, the same principle applies to security in the cloud. Security in the cloud might be, you want to make sure you have denial of service protection at your border edge. You might have to isolate stuff at the network as well. You might have to treat and make sure that you have antivirus for your EC2 instances. You also want to make sure that you have proper identity access management, these privileges, encryption at rest, as well as in flight, for what you need to do for your systems. Now, you also want to automate security best practice. As a security and professional in DevSecOps myself, we always say automate, automate, automate. And you can't never have enough automation. Here we see in our diagram that we've automated multiple security controls, and we also have a hub and spoke model. We have multiple accounts. We have a central security account here, an auditor account here, and a set of managed AWS service accounts, one or more of these. And ultimately, we have centralized security services monitoring all of these accounts, including the audit account. And we want to make sure that we have everything in one place. And we also want to make sure we have automatic remediation and automatic detection. It's not enough to have CloudTrail logs just sit there. You have to analyze it and do something with it. Humans are really bad about this. You can't just analyze millions of lines of log files or code and be expecting to hit every single security context or alert or issue. Automation is really for that. And so you might use different services such as Security Hub, AWS Config, and third-party solutions for that. Remember, the name state is to really get automation as part of your security operations, and really think about it. Anything in the cloud, you should pretty much automate. Next, we have protect data in transit and at rest. Some people think about this as in terms of encryption only, but you should think about encryption as one piece of the pie. So encryption meaning that you don't want anyone else to read something over a channel in case someone captures your content. So if you're logging into a bank on a website, you naturally want to have encryption in transit, SSL, TLS, and you expect your bank to say, hey, encrypt my login and password because I don't want anyone else sniffing the traffic to be able to read and get into my account. That's encryption in transit. You also want to make sure that all your transactions and anything, including your password, as you use to log into account for authentication, is encrypted at rest at the database side inside your bank information. Encryption algorithms such as AES 256 standards are required for protecting data in transit and data at rest. However, that's not enough. You should also practice least privileges for IAM authentication. Should every user be an administrative user? I hope not, right? It would be terrible if I had IT admin privileges if I was a normal banking customer. So least privilege access and really privacy laws. So if you're in healthcare, you might have the HIPAA security rule, but you also have the privacy rule as well. Consult with your information security team as well as your legal team to determine what is required for data protection in transit and at rest, including privacy requirements. Now, also part of security is keep people away from data as a whole. Right? This goes into the least privilege principle. If you don't need to be touching data directly or transferring data, let some sort of automation do that for you. That actually rolls into part of what we've been doing in the last 2 or 3 design principles. So less manual requirements means more automation and more consistency and robustness, and reducing the risk of accidental exposure or mishandling of information. You don't want to transform an accidental record, something like a patient for a healthcare facility, providing typos when an automated system could do that for you, right? You wouldn't want to put measurements from an IV drip directly into the EMR system. You might have that computerized or over the network and is already monitoring in real time. So rather than have a human do that, which could make a mistake, let the machine do that for you. The same thing goes in the cloud automation. Our final design principle for security is prepare for security events. Now, we want to make sure that you are testing via penetration testing, or you're also making sure that you have all these above, which are including visibility, principles of least privilege, security, best practices, well-architected, high availability. You're going to prepare for all of this, and you want to run testing and simulation whenever possible. We have services like AWS Fault Injector Simulator, which can help you with your experimentation and help you understand if your application is ready for production or not. Because as soon as you make that available to the internet, everyone's going to have access and you'll be attacked nonstop. So are you prepared for that security event or incident to auto-remediate that or prevent it altogether? That's up to you. Now, our next pillar is reliability. Design principles include automatically recovering from failures. So at any point, if you have infrastructure as a service especially, a virtual machine can fail at any point for any reason, and it could be related to a number of things. It could be AWS's fault. It could be your fault. It could be a bad Windows update. One such example is the AWS Support Execute EC2 Rescue documentation and automation. that is based on AWS Systems Manager, and that will automatically try to recover a machine that is not bootable uh, by utilizing automation and recovery scripts that can help that out. Other automated recovery cycles could be a bunch of different things. Automatically restoring from a backup when there's a failure, automatically switching over from a dead network from one VPC to the next and high availability. Those are principles of automatic recovery from failures. You want to make sure that you have those built in whenever possible. Remember, the keyword of the day for anything in cloud is automation. Try not to do things manually whenever possible. The next one is testing recovery procedures. It's not enough to have potentially automated failover, but you want to make sure that you test it. Now, here's a favorite picture of Kong and doing some chaos inside a data center server. We can actually call that chaos engineering. Funny enough, Netflix, which is one of AWS's customers, in 2010 actually made chaos engineering really popular by releasing their white papers and tool sets to help others understand that you can cause complete chaos inside your data center. Is your solution robust enough to handle that chaos? Can it auto remediate? Can it auto recover based on our design principles there? You have to test this. By testing this, some people went into the data centers and actually started pulling plugs on random servers to see if they could recover. So you may not have to do it that intensely, but at least from a software perspective, or at least from a disaster recovery perspective, always do your testing and procedures whenever possible. And again, automate, automate, and automate. Now, speaking of recovery and resiliency, we also want to make sure we can scale up. As demand changes, as your product changes and your demand goes up, let's say you have a really popular application or something, you want to do horizontal scaling. Now, what does that mean? Horizontal scaling. Horizontal scaling basically means instead of you adding more RAM or adding more CPUs consistently to one single EC2 instance, which is considered vertical scaling, you want to do horizontal scaling, which basically adds more nodes of the same launch type. So if one of them goes down, you're not dead in the water. You're actually still at reduced capacity based on what you're looking for, but you're not dead in the water. And that is increasing your resiliency and reliability at the same time using horizontal scaling. Again, horizontal scaling, just think of clusters and nodes, adding more node to your cluster as opposed to adding more resources by adding RAM or CPU. Now, another design principle of reliability is stop guessing capacity. Now, for those of you who are not in the IT working space yet, usually when we try to size something, we try to size something from a 3-year life cycle. And when we say we create our own hardware or our own data centers, we actually call something an end of service life or EOSL. Some might call it EOL or end of life. And again, these are anywhere from 1 year or 3-year life cycles based on the fiscal year of your financial services planning. You'll have capital expenditures to actually buy all these equipments, hardware and software, and then you have to figure out what is my software and hardware going to look like in 3 more years? What's my demand capacity? And you'll have to make that forecast, but really you don't have the previous data, or you might not have really good data, and you might have to do guessing based on your on the strategic alliance needs of your executive leadership. So we want to stop guessing that capacity and use automatic scaling whenever possible. Automatic scaling is inside the EC2 portfolio. The portfolio basically says anything with infrastructure as a service and really platform as a service can scale up and scale down automatically, but you don't have to most of the time consciously think about this. In the infrastructure as a service, especially with EC2, you can set your desired minimum state and maximum state for what your desired needs are. So if you need to make sure you have 500 users of playing capacity at any one moment, you have a certain number of EC2 instances accordingly, and then you have a max out to determine what is realistic and what's required. Over time, you might have erratic changes, and you might have days of the week where things are higher or lower. You can use schedules, or you can use dynamic adjusting based on CPU utilization, memory utilization, other key metrics that you might have for the previous pillars, and you'll adjust accordingly by scaling out and scaling in. Scaling in means removing one or more instances or other nodes from your cluster, and scaling out means adding to that. Another portion of reliability is also to make change management automation. Now, change management means a lot of things to different people. Ultimately, change management is any change to the environment made for production that you must document and control, potentially approve using manual review, or use automated testing whenever possible. For those of you who have some sort of DevOps experience, this might be referred to as continuous integration and continuous deployment. CI/CD pipelines, and that handles the changes that occurs specifically here in the deployment phase based on other principles. Now, to your left, you might see what we call AWS SSM, which is Systems Manager. And this allows you to have automated scripting of configuration states. What do you want executed? Do you want to deploy a application? Should a certain patch be involved? System Center has change management workflows as well as ways of automating those changes inside your actual resources. And those happen through the form of documents inside Systems Manager. You'll learn more about Systems Manager in later modules. But for now, understand that automation is key. You want to be doing this by hand, script it, right? Let it get deployed at a certain time interval based on approvals, and then kick back and watch to see and monitor if it was successful or not. Now, our next pillar is performance efficiency. Our design principle, we want to make sure we democratize advanced technology. So, not just relying on traditional virtual machines, which we maybe have migrated really quickly to get to the cloud, but container-based applications such as Docker or perhaps AWS Lambda, which is full serverless altogether. Lambda, if I can actually spell. Anyways, you want to make sure that users also have that ability to request different technologies as needed. Users including DevOps engineer teams. So if there's an application that needs to be built, you shouldn't have to wait on your IT team to get trained up on it, to really understand that technology and then approve it. You want to have a portfolio list of advanced technologies available at any point and really encourage users to be self-served. Self-service, request this, you get it, and we have very specific standards and requirements saying that you still can't do whatever you want, but here are the approved options that you can do, and take your pick based on what you need. This is great for self-service being DevOps, because now developers and people who build as applications or workloads can finally say, well, I need an environment built up in the next 30 minutes, maybe next week, and I want to make sure I have the best practices on what our standards are in our enterprise, including our patterns, and I might select from a menu, then customize it with my own code and inject what I need, and then deploy it really quickly. Creates performance efficiency, and also creates value add and cost effectiveness at the same time. You also want to make sure you go global in minutes. So selecting the right services really means a lot and what makes sense. Is the service you're selecting available in that region of the world inside Amazon Web Services? Do you have products that can be portable? Something that's less portable might be an Amazon machine image that has an operating system and all these things that have to be patched and go with it when you migrate it or copy it to another region. Or maybe a container might make more sense, or even an AWS Lambda, so function as a service. You just send the code, gets replicated, go through that. CloudFormation infrastructure as a code can help out with a lot of this. So ultimately, does the services and products that you select as part of your architecture, can you actually deploy in other regions and go global within a matter of minutes based on what you need inside your account or multiple accounts? You also want to pick and choose, and whenever possible, a serverless architecture altogether. To your left, you'll really see here examples of pure serverless architecture. None of these have any form of virtual machines, OSs, or anything else that you manage from a server standpoint, traditional IT standpoint. Now, you'll do this on premise, but you won't do this in AWS. AWS is using platform as a service or even SaaS can really help you scale this automatically based on how you want to tune and configure, including DynamoDB. So ultimately, you don't have to worry about servers. You don't have to worry about patching. And ultimately, the resiliency, where it gets replicated, if you're using multi-region or global service, it's always going to be resilient for you because AWS is doing that back-end work, that heavy lifting for you. You also want to experiment more often. So because you have improvements in efficiencies and you have improvements on the type of technology that you're selecting, you can also have infrastructure as code, application code, along with that infrastructure as code deployed. Now you can experiment. Can I instantly send something out, see how it works, and then roll it back if there's a problem? And I can do it cheaply because I don't have to keep that, I don't have to buy the hardware. I don't have to buy the capacity and leave it running forever. I can delete it and destroy it at any given moment. You cannot do that with on-premise. So experiment more often whenever you can because it's cheap enough to do so. And that way you're going back to don't guess. Always try to figure out, get the data, and get the results that you're looking for to continue forward in your efficiencies and improvements for your workloads. Now, next, we have to consider mechanical sympathy. Now, what does that mean? Mechanical sympathy. Well, when you're looking at DevOps, DevOps serves really a different supportive role. It's supporting developers with automation and tooling that developers need to get code out securely and deployed. Supporting operations and the fact that they're handling the infrastructure and or if they are, or if they're handling all the configurations that developers need to actually produce. So not focus on necessarily traditional corporate IT or anything like that, but when they're working together, operational corporate IT, developers, and DevOps as multiple teams and tiers and groups, you have to really consider what goes involved. What is the level of effort? So the key word here is level of effort. Right? What is the scope of my data, the systems? You really have to consider, all right, do we have the resources? Are we allowed to use NoSQL? Do I need to use SQL? And that limits us to what kind of services we may use. What's our budget? And can we maximize that budget using the cloud? Or do we need to make considerations for having a hybrid based control based on something like regulatory needs, federal requirements, isolation needs, or just the management's control needs for their own assurance? So ultimately, have that sympathy for other teams and groups. You'll go a much better way with DevOps as a culture and mindset shift rather than from a technology only efficiency perspective. Our last and final pillar includes multiple design principles as well. You want to implement cloud financial management. Now, this is a little bit different from what you mean by financial management in general. Every organization has finance, they have sales, they have cyber security, they have IT. Cloud financial management is different operations. You're not worried about CapEx anymore. CapEx, remember, is about hardware, capital expenses. Because financial expenses, they want to depreciate those assets over time, usually over 1 to 3 years. And because you're depreciating those assets on the books, that has tax implications. So we're not focused on CapEx anymore from a financial management perspective for cloud. We're focused on OpEx, right? What's our operational expenses? We need to understand what it costs each month to operate these workloads or clouds. And you really need to understand that difference. And so take some time to talk with your financial teams about what this means to you. Ultimately, you need to implement and plan for the changes of what cloud differences and how you classify CapEx versus OpEx, and what are the strategies that you need to actually monitor this. Provide them the billing dashboard and other resources possible to your financial team, and you can really help them make better decisions and choices on how to fund your workloads. Now, you also want to adopt a consumption model. Remember that you stop needing capacity, stop guessing capacity, plan for what your technology should be, focus on your code, and try to get the feedback from your customers. So we want rapid feedback and innovation from our customers using a loop cycle. The consumption model basically means that you're also just grabbing services. You're less focused on undifferentiated heavy lifting. Say that 3 times fast. So basically, all the heavy lifting that is done by traditional IT needs to really be about services. You have them as a service. EC2 is a service. AWS Lambda is a service. S3 is a service. Everything's a service. So consume that service. Focus less about the basics of building and focus about innovation. Focus about business value. And once you release those products and business value based on agile development and other practices, you have a continuous feedback loop with your customers for faster releases, faster iteration, and ultimately faster feedback that comes back to you to make a better product. Measure overall efficiency. Just like everything, finance, performance reviews at your workplace, everything must be measured. So we have a breakdown here of the billing dashboard that includes what types of services are most efficient, potentially based on our costs in thousands of dollars. Now you might want to say, well, maybe it's we have less efficiency if we're using a smaller CPU instance versus a larger instance. We don't know. We have to actually find out. When we dig down inside the billing and reporting details, you can filter based on services rather than have a macro view. You can figure out how efficient we're operating on different service platforms and potentially tags and other information like that. Overall, you want to measure everything possible within what you're using in AWS environment. So the billing dashboard is really out there for you. create reports, and really get notifications on how you're doing and how your workload is operating, impacting the bottom line to your company. Again, we mentioned stop spending money on undifferentiated heavy lifting. Now, what does that mean? Well, that basically means stop doing normal traditional IT stuff. Focus on what matters to you. Focus on business value driving ads. Figure out what makes sense to your organization and what level of commitment you have to go into the cloud. The more that you commit to AWS doing these services for you, the less you have to worry about all this underneath and more about focusing on your application, your core logic, your development experience, innovating for your customer. So if it makes sense to you and it makes sense to your organization, move closer to PaaS and SaaS, right? Some places use Office 365. They don't even host their own Exchange servers anymore for email. Some people use S3 for expanding their service platform instead of owning SAN storage arrays and building hard drives or NAS network attached storage platforms. Right? All of this is possible with the advent of cloud, and it could be cheaper. It depends on you and depends on your business classification and needs. Finally, we have analyzing attribute expenditures. So, just like you want to measure efficiencies across different classifications, different services, maybe you want to attribute everything, just like you do with any identity, to a very particular product. How's my product doing? Is it being over budget? Are we within budget? Right? You can actually measure that efficiency at the user tag level. And as we can see here, if you zoom in just a little bit more, you'll see that you can tag different resource objects altogether. You can tag users, virtual machines, SQs, whatever it may be. And then you can monitor the actual consumption of each resource based on the tag and understand where your departments are writing in efficiency, where your projects are writing in efficiency, and ultimately have that attribution that you're looking for each expenditure type. So let's take a quick break, and then we'll get on to some additional form factors and information about what good looks like and what patterns look like. I'll see you in a little bit. Okay, welcome back from our break. So, well-architected patterns and the well-architected tool is what we'll be going over today. We'll really need to think about how the well-architected framework aligns to these patterns. Why are they well-architected as opposed to not so well-architected patterns? So we'll look at both of these today. So let's get into that. So let's think about what makes this a well-architected pattern here. So this is actually something you can pull back inside of the this URL right here. But here we have a scale-out computing resource used for virtual desktop environments. So we have users that can monitor their own costs, which is something that was part of your cost optimization pillar. And then we also have cloud formation stack that we see right here. So that's part of our operational excellence. So infrastructure as code. We have multiple serverless applications and products being in use here. So that's also a great way for efficiency and performance efficiency and reliability in the same aspect. Now, for some of our IaaS stuff, we also see that we have multiple app availability zones, right? We have multiple areas that we could fail over to in the event of an issue, and we can also scale out. So also a great practice for resiliency, performance, and tuning, and our separation where available. So we have separation of assets here as well as right here, and we don't have direct access from the internet, right? If we're looking at here, we're actually looking at security as layers, and we don't have direct access to the internet. We have a load balancer proxying this for us and making determinations. So we don't have to actually expose a public IP or our internal IP space. We have a single load balancer funneling that for us. We also have the ability to use secrets manager, so we store passwords in encrypted ways and have those rotated as necessary. We have the certificates manager, which will allow us to have protection in transit as well. Then we have our identity management as well, and many other things that make this a great architecture. Pause the video, see what else you can find that is part of an alignment to the well-architected framework. I'll wait. Okay, if you found other things, that's great. And if you can name them and draw them all on your own sheet, that's even better. Let's move on to another pattern. Now this one's an algorithm trading platform for financial services. So what we have here is an actual customer, And what makes this a great architecture? Well, again, we have to look at this is completely serverless now. We don't see any EC2 instances in here. So we have advanced technology democratized and in use. So in this case, we're using all serverless technology, containers, and all kinds of stuff. We're monitoring everything via uh, KPIs and metrics and tuning requirements. And then, of course, we have just keeping it simple, right? Not overcomplicating things, keeping everything through a managed service whenever possible. And then we don't have any public access for that. So even better for a security perspective, we don't have public facing access. We don't have anyone trying to get in. We have exactly what we want. And hopefully with IAM privileges and everything else that you're monitoring with these monitoring based services, you have least privilege access and you can do all those accordingly the most efficient way possible. We also have microservices architecture, so non-monolithic. Again, part of serverless compute, only have the direct APIs or functions that need to be hosted. Have your application call those whenever it needs to be called, not having a single point of failure here. And before we go beyond that, make sure that you pause the video and understand where each best architected review practice is and design principle based on what you see here. Feel free to pause the video. I'll wait. Okay, moving on. We'll move on to our third pattern here. We have a lab instrumentation and acquisition analytics. So if you work for any hospitals, anything like that, or pharmacy places, they have labs that ingest data. And they ingest it using modality-based devices. So they might ingest it via offline on-premise file servers that push it out to our highly available services. So we're completely serverless again, which is great. We also have potential security in layers, so we don't have direct access, and microservices architecture using API gateway. And we also have external identity management, so we have Cognito managing that for us that can identify each user to each identity, what has been done, and then do that analytics accordingly in these nice little pipelines here. Again, we don't have any issues. The only thing I could say that could be improved upon is, actually, no. Let's look at number 9. We have SQS, which is asynchronous services. So we have a buffer. In the event that the S3 or Lambda or the gateway sends data to this buffer, we don't have to worry about one having an overflow issue and then stopping up and holding up the line. We can still keep filling up this buffer and we'll never lose any of the events. Pretty important when you have scientific findings. And of course, we have our proactive monitoring accordingly and our KPIs for costs and many things like that through CloudWatch events and other things to keep our solution healthy. So pause the video, look at what else makes sense to you from an AWS well-architected framework perspective. All right, let's look at some anti-patterns now. One of the main aspects is monolithic architecture. We talked about this earlier. We want to go through microservices applications, containers, APIs. Lambda functions are just for that. But the problem is sometimes you get saying, well, there's serverless architecture. I'm already highly resilient, and I only have to worry about it. That's simple, keeping it simple. Hold up here. Remember that Lambdas need to have a maximum runtime of 15 minutes, right? They only have a maximum runtime of 15 minutes, and you get charged by the, as of 2020, the single millisecond rate. However, remember, you can only have 128 megabytes of memory through 10 gigs of memory. Now, the key important part of that is if you understand the AWS Lambda service, you also have only 500 megabytes of scratch storage space, temporary space to process data. So you can't just pull whatever you want that has multiple gigs that has to be streamed. You can pull it. You need to pull it via another decoupling. So you can't have Lambda do everything. The better thing to do from a best practice standpoint is have a non-anti-pattern, right? Have the correct pattern of saying split Lambda up, create multiple Lambdas that do one specific thing and do that one thing really well. So you're one, reducing your actual invocation time, and two, reducing your possible points of failure in the event that there's a anomalous data event occurrence. Let's say here, you're not affecting these Lambdas for these types of functions here. It's only a small impact as opposed to an all or nothing impact. Another pattern that we find quite issue with is non-resilient or non-security based layers. I am directly being accessed from the internet here, and even though I might have a host-based firewall security group, I'm exposing a public IP and internal IP, and I don't have anything else in front of that. I can't do anything. Notice something else. I'm only in a single AZ. I can scale. I don't have replication going on. So I must scale horizontally and keep adding resources if I want to meet demand. There's no denial of service protection for me. It's just bare open to the internet. We don't really want that. So the better practice pattern is to actually make sure you use multiple availability zones and then put in an application load balancer or a network load balancer, anything in front of your EC2 instances that make the most sense. Remember, you are using IaaS in this case. You still have to manage all the underlying infrastructure from the network configuration upward. And so what we have here is high availability with resiliency. We're having security here where you're not exposed to the internet directly. And then we have scale out, scale in capabilities based on auto scaling requirements that give us a little bit more horizontal scalability requirements and security requirements at the same time. Our final anti-pattern type, which we commonly see, is event-driven services, but with synchronous responses. So a synchronous transaction basically means I'm sending something to you to the server, and I expect you, the server, to come back with the same answer from the same server. Now, using AWS Lambda, you can actually utilize asynchronous event-based driven context. And so even though you might invoke an event here, you're still saying, hey, I need to depend on a response from S3 and depend on an OK response from DynamoDB for table. And then I can stop and provide that response back to the end user. Well, that's still taking a lot of invocation time. Why not split that? Again, decouple that. The best practice pattern is to decouple everything. So split that into two Lambda functions right here. Lambda function here and here, and having chain events going on. So you don't have to have that single invocation time being spent because you're being charged by the amount of time it takes. Remember that events be passed from each other. So utilize this, couple those, decouple those event-based driven architectures together, maybe put them into an SQS queue, and then have that response being sent back directly from somewhere else upon completion. Maybe the DynamoDB table. Maybe you don't care about sending a response back directly from S3, but the DynamoDB table might need to be the 200K you send back, 200 status OK that you send back to the end client. And so that's where you want it from. You don't want to wait for S3. You actually don't have any dependency on that. So you want this Lambda and this DynamoDB to send that directly back to your client. And again, asynchronous, right? It's not the same Lambda that you sent data to. It's a different Lambda or a different DynamoDB table or a different origin, essentially, that you want to send from in a response. So asynchronous is really the way to go. If you're having decoupled patterns, keep it decoupled. Don't rely on synchronous items. This is going to help you for performance efficiency accordingly. Okay, so we're done with our anti-patterns. Let's look at a little bit more about the well-architected tool itself. And the well-architected tool is not some magic thing that makes your workload any better by automatically, but it does help you identify what your risks are, issues that you can improve upon. So you define your workload information in there, the different aspects. You'll be asked questions in part of a review cycle to determine what components your workload has, what industry you're in, and it will help you make recommendations as if you had an architect with you. Now, this is free, and you should do this with every workload you plan and build to determine if you're meeting the well-architected framework best practices. And again, this serves as a best practice review. This is not going to stop you from building incorrect patterns. This is based on what is recommended to you. Obviously, take it with what it means from a business. Align what it means. Not every risk or every improvement requirement needs to be implemented directly into your workload, but you need to consider it at the very least. Now let's take another break, and then we'll come back for the demo. Hi, and welcome back. Feel free to follow along if you wish. You'll also be doing this partially in your labs too. That's all I wanted to showcase a little bit more about what we talked about. Now, we've shown Trusted Advisor in the past, or if you looked at it in your lab, and this helps you understand your best practices and some of your well-architected frameworks in there, like cost optimization, performance, and security, and then your reliability and fault tolerance. These are recommendations here. And notice that I have some recommendations here that I have an unrestricted security issue, and I can also resolve that and see if that's resolved by a refresh. So I wanted to show that to you to give you a nice overview of what you can see as a snapshot in your account. But more importantly, let's go to the well-architected framework review tool. So well-architected tool, and it's a free service, so you don't have to worry about paying for it. And I'm gonna go ahead and delete this. You can always create a new workload, so I'll define the workload. Give it a unique identifier, obviously, a description that makes sense. The review owner, preferably your simple email here. whether this environment is going to go to pre-prod or production, so non-production. Which region I'm going to select. So I'm going to use US East 2 in most cases. My account IDs, if it makes sense. Where my architecture design looks like, so a URL to the picture, and potentially in the industry type, maybe healthcare, for instance. And then my appropriate tags. I want to say I'm project, sonar or something. I don't know. You pick. Make sure it's identified. Make sure you have a key value pair, and you can add up to 50 tags for every asset. I want to look at it from AWS Well Architect Framework lens, but you can also add additional focus points here. And then it'll ask you a series of questions. So you don't have anything here. You just have basically say what kind of review I should do. I'll start reviewing here. And then you'll answer all throughout here what makes sense to you. And try to select what something meaningful is. And maybe if you understand where something is that you would never do, but you want to see what the recommendations might, make sure you check something off, make some notes, and save and exit. And you'll eventually generate the report inside the workloads viewpoint here. So go into your workloads, and then as soon as you're done with your review, you want to generate the report, and you'll get your recommendations accordingly. So have fun with that in your lab. I'm going to delete my workload. It's free. You don't have to worry about it, but you can leave it there if you wish or not. Now, that's one aspect of it. The other aspect I wanted to showcase was CloudFormation. So CloudFormation, again, this is infrastructure as code, and this is really part of the operational excellence pillar of this. So you can create stacks, and the great thing about that is you can actually go into different workshops. So we'll go into one of the well-architected workshops that you might see here. And I'm going to go into operational excellence, which goes into the 100 lab level series, if you can follow along if you wish. And then we want to use inventory and patching and something like that. So we'll use something like this. And you can set up different things based on what it's looking for here, or perhaps operational efficiency and cost optimization, whichever makes sense to you. Now, the other lab requirement that I want to use is actually right here. And so I'm going to use the reliability lab, specifically around CloudFormation. Now, infrastructure as code is still an operational excellence need, but here is a good way to get your feet wet into infrastructure as code on what you can do. This is what you'll be building. Now, remember that if you keep this on, it'll cost you roughly $5.50 per day. But if you delete it right after you do your lab, you won't incur too many charges. You might incur a few cents at most. So this is what you'll be building using a one-click CloudFormation template. We'll start the lab. I'm not going to go through every process here, but ultimately you'll create a CloudFormation deployment and deploy it accordingly. So I'll use this as my template, which will be one of the two templates you'll be using. But I just wanted to show you that infrastructure as code is definitely possible. You can upload this as well. Again, this is YAML. You want to see what the actual YAML look like. Again, this is just a definition of what we want inside our account. What an infrastructure as code, the deployment of the hardware. It's kind of cool, isn't it? So automate, automate, automate. All right, we can use a sample template if we wish. I'm not going to use it. Again, you can also view this in your designer, which shows you visually what to do and how it looks. Because it must be an Amazon S3 URL. Oh, my apologies. So let's go back. And it was not part of an Amazon S3 URL. So we can always download it. So let's download it, upload it ourselves. So I already have that here. We'll replace it. And we'll upload the template directly. And then we'll view this in Designer because it's uploading into a temporary CloudFormation stack. And here's a visual version of what we'll be building. Here's the JSON notation version in YAML. Even though we upload YAML, it'll convert this for us. And that's pretty neat. And I'll just say I'm pretty satisfied with that. I'm going to go back to my wizard here. We'll reference the URL accordingly. Template is ready. And it must be a supported URL, unfortunately. So what I'll do is I'll upload this instead. I'll click next. I'll select whatever this means. And cool. I'll say my set name is test. I'll say next. I can add my tags like project Sonar again. I can select the role, so I can set a quick local setup template or whatever makes sense to me. I'm saying this uses all stack templates for the roles. So basically, a role is something, a set of permissions that you give an Amazon service permission to do whatever you want in your account. And then we'll click on next. We can review with your stack. And again, it doesn't have permissions because I don't have the right role added to it. So what I'll go ahead and do is I'll create that role required. So what I'll do is create a new role. So we'll say, I'll go into our IAM. And a role, again, is just something you create for things like CloudFormation and stuff like that. So I'll say I'm doing all these things in EC2. And I'll use all EC2 services on my behalf. That makes sense. And I want CloudFormation to have everything it needs. So I'm just going to say, now you naturally want to use the least privilege possible, but for our purposes, for this demonstration, we're going to use full administrator rights. Again, you can actually see what those rights look like down here in a permission template here, which allows star everything. Again, not the best security practices, but just want to show you for quickly showcasing this. We'll add a tag if you wish. I'm not going to add a tag. And I forgot to add a name to this role. So create a trusted role, MN access, new tag, create the role name. We'll say CloudFormation admin role. I have a policy attached to this role. I'll create the role. And then we're going to go into, let's go ahead and go into our CloudFormation again. Create the stack. We'll upload our template. Next. We'll say test as our stack name. Could be anything you wish. Remember, that's just unique to your item. And then we'll select our role accordingly here. So it looks like I'll use the defaults. And I'll select my role name, and it's unfortunately not showing me the correct role because we don't have a CloudFormation setup role that we're looking for. So I must have missed a step here. And what I'm saying is I need this role here, so I can actually use a different role for that. So rather than use that, I'll just use a different template instead. That's okay. You'll learn it in you'll go through your stack accordingly. I'll create a sample template stack, and I'll just use a lamp, like any stack here. So I'll use a WordPress blog, which is a single instance here, which is cool. And again, you can go into IAM roles there accordingly. And so this is the same kind of CloudFormation template as you're going through. And then, of course, let's just use this instead and deploy it. So I'll say test stack, and I'll say my password. Again, these are not secure whatsoever. And then we'll go ahead and use a key name, which I've created. You'll have to create this ahead of time. We'll put a tag name if you wish in there. I'm not going to do it, and I'm going to deploy it. It's going to tell you, oh, wait, you're doing something that might cost you some money. That's okay. Create stack. And now it's actually deploying infrastructure as code as we speak. And if you look at the outputs, it's going to have creation in progress. And while it's doing that, let's into the IAM items and see what kind of roles I actually need to put. I think that's kind of interesting that we're missing the exact role we're looking for. We'll go ahead and delete the other roles since it doesn't seem to show up properly. Remember, delete what you don't need. Keep your items clean inside your account. And we'll understand what needs to happen here. So CloudFormation is not part of the items here. So we'll say, I'll look back at the other roles and figure out what happened here. So I'm not sure, well, AWS CloudFormation. This was not there previously. And what is our permissions? Execution role, local stack. That should be fine. Well, so we'll try the AWS service again. And I think it's funny that we need to, I didn't select CloudFormation as my service, so apologies. We'll do admin access. And again, this is how you would do it correctly. CloudFormation admin role. And I'll put that in my description as well. Oops. And I'll next. And that role should be created properly here. And my test stack should be created, or it's still in progress. No outputs here. Still being created. This portion is great. It's creating a web server security group. And we can see if that's actually created inside our EC2 VPC here. So we'll type in security groups. And we'll go to security groups. We'll open that in a new window. We'll refresh this here. That is created. Our web server is completed and our instance is created. So this is all completed and deployed. There are no outputs, and it has a website already given to us in the CloudFormation community. So here is my website. It's completely accessible via public perspective. So it's to the internet, and it's my web server. I have a security group that's been created for inbound that allows 80 and 22. Not exactly the most secure, but not exactly a great practice. But this is a really great way to show you a very simple way of having something as CloudFormation doing infrastructure as code, and we have now a VM running that we didn't have to manually do. And the best part about all of this is that this was completely automated. It took maybe a minute or two. It told us exactly what we were doing here, and like magic, I can actually delete this as soon as I create it. And if I delete this stack, it'll actually delete everything it just created inside that, and it'll roll everything back without me having to go manually fumble through the console here. So we create another IAM role. This time I corrected it properly. So your IAM role should be based on, if you don't have those permissions, make sure you're using the right permissions for the service type of cloud formation. Right? You'll find it right here, service type cloud formation. And then if you upload your template yet again, I'll go back to my stacks and we'll create a new stack. Upload that, we'll use upload a template. And then we say next. Oh, say my test lab. And now my role should say right here, and it should say, hey, you'll use this role for all stack operations, and I can click next, and it's not going to give me an error anymore. And I'm not going to click next, but again, this shows up because I used the right role with the service combination. So be sure to follow your instructions precisely and don't skip them, otherwise you'll run into issues like that. All right, so let's take a look at our CloudFormation stacks and make sure that we are clean. We don't have any stacks. And let's go back to our security groups to see if it's still there. Security Hub is not what we're looking for. Do not enable Security Hub because it costs money. So try to stay within the free tier portion. But it's still pretty cheap if you want to enable it. So my security group is gone related to the web server, which is awesome. My instance is gone as well. It's been terminated, even though it's still showing here. Basically saying as soon as it goes to terminate, I'm not being billed for that anymore. And all is well inside my account now. I don't have to worry about anything else of cleaning up. CloudFormation did that for me. So thank you for joining us, and we'll see you in the next lecture.